So here we are discussing a new topic, that is enthalpy of interconversion of states of matter. First of all, we need to understand what the topic says. Enthalpy. Enthalpy basically means heat. Enthalpy means heat, right? Interconversion means changing. Talking about states of matter, so we know what is state of matter, right? There are 5 states, like common there are 3, but if we talk about other than that, so we have 6 states of matter, right? So now states of matter are divided into 2. Now what are these 2? These are basically common and non-common. As I have mentioned here just few minutes before, that common as what? Solid, liquid and gas. And if you talk about non-common, so they are plasma, Bose-Einstein condensation, I am writing short form here, and third is fermionic condensation. So these are the state of matter, these are common and these are non-common. So we know what is solid, what is liquid and what is gas, but like plasma is something that is rare, Bose-Einstein as well, and fermionic as well. So we'll be discussing all of these. So first of all, interconversion, as I mentioned here, so the conversion of solid to liquid is known as melting. Liquid to gas, the conversion between them is known as, we are converting liquid into gas, so this is basically known as evaporation. But the most appropriate word for this can be boiling. Now if we go from gas to plasma, for going here, like from gas to plasma, we require very high temperature. High temperature, I mean like more than 3000 or kind of something like or it should not be the ordinary temperature. If you are gonna be heating it in the same temperature, so it is not gonna be converting. So it was boiling, right? Now gas to plasma, so this is known as ionization. I'll be explaining this as well. Okay, so I guess I should explain ionization first, right? Ionization. Now ionization has 2 types, right? Now what these 2 types are, first of all, let me give you it by an example. For example, we have H2. H2 contains 2 electrons and 2 protons. So this is a nuclear part, it has 2 protons, and if we talk about outer shell, so it has 2 electrons, right? So as I talk about ionization, ions mean converting into positive and negative charges is known as ionization. Okay, so I have 2 protons here and 2 electrons here, so these are, for example, in the bucket, right? So this is a nucleus. So now here we have an attractive force. Now what this attractive force is called, it is known as electrostatic force, right? This is between electron and proton. So maybe you have studied, maybe like I have studied, so this is basically electrostatic force. Now as I mentioned here, we require a very high temperature here, like you cannot convert this into this on like ordinary temperature, right? So here we'll be providing it high temperature. By this high temperature, this high temperature will break this electrostatic force of attraction here. So what is gonna be done here now? Here, like we have atom, here will be 2 protons that are positive plus 2 electrons that are negative. So here you can see that they are converted into charges, like here positive, here negative. So this is known as plasma. What this is called, this is known as plasma, right? I hope this is clear. Now if we talk about second type of ionization, so this is first type of ionization, this is second. And do memorize that not every ionization is known as plasma. Plasma will be only in the condition if we have a very high temperature. Now if we talk about the ordinary ionization that I am talking about right now, for example NaCl, here we have a electrostatic force as well. Now when we will be providing it temperature, like here we are not providing it temperature like in thousand, more than 3000, let's provide a temperature of 800, right? So when we ionize this, so it will be Na plus Cl. Like here only they contain covalent bond, right? Yes, they have a covalent bond. So here only the covalent bond is breakdown. There is no breakdown of Na. Like Na contain its electron and proton. So here the bond between them is not break. But now if it would break, so Na should be broken as well. Like only these are break. Only this bond is the bond between Na and Cl is break. So they are converted into this. So I hope this is clear. Here we don't have a high temperature. If we talk about this, so we have a high temperature. The main cause is the high temperature here and the electrostatic force. I hope this is clear. Okay, so now let's move to conversion, right? We were here. Now if we convert, now Bose-Einstein is basically the state where we have very low temperature, or you can say coldest temperature, right? So here we have very low temperature, coldest temperature. Okay, so now conversion is clear to you. Solid to liquid, it's called melting. Liquid to gas is known as evaporation. Gas to plasma is known as ionization. Alright, this is clear. So now we are talking about, so I was talking about enthalpy as well. So I have not used here enthalpy in any term. So now let's use enthalpy as well. So enthalpy, I was talking about heat. So when we ionize these gases, so for example we have NaCl. Let me ionize this, let me heat it. When I heat this, so it become Nag plus Clg. Maybe you have seen this many times but maybe ignored, because I do that as well, but now I get the importance of it. So we have gas here. This basically means the gas, let me tell you about gaseous as well. Gaseous basically means so yes, the gaseous phase basically means that we have gases involved in it, right? So here we have gas involved, so we'll write here G. And if we talk about NaCl, let me put the involvement of H2O. So do you think here we have this as well? Like we'll be writing the same. For example, G, here we have involvement of water. So the answer is absolutely no. We cannot write gas here because this is aqueous solution. So we'll write NaCl. We've given water to it, so it will convert into Na aqueous plus Cl and positive, Cl negative, and that is also aqueous. Okay, so the third type of ionization, that is, no, ionization is of two types. From the the three kind of ionization make it. I'm just gonna be making a chart as well. Just give me a minute. Now NaCl. Now if we have dissolved this in solvent, so it will be NaSOl. Mean it's a solvent plus Cl, that is also a solvent. Okay, so if we have heat, so we'll be write G. If we have water, we will be writing aqueous. And other than that, anything is there, so we will be writing this solvent. I hope this is clear. Now I was talking about ionization, right? Like I was talking about how many type of it. Ionization is of two types: anion, cation. Now these are formed by three kind of. Like states. One is aqueous. Second is what was it? Gaseous or heat. And if we talk about the third one, so it was solvent. I hope this is clear to you. So this is all about the enthalpy of interconversion. So thank you.